Hi guys, and welcome back to another lesson in Algebra 1. This is Unit 3, Lesson 5, and we are going to be comparing discrete versus continuous functions. Okay, so our objectives for today is we need to know what discrete and continuous mean in terms of functions. So like what do those two words mean in that specific math context? And then the second part is that you can recognize discrete or continuous functions in either a word problem or a data table or a graph. Alrighty, so let's go give it some definitions. So discrete is going to be something that has individual points of data. Okay, and the data would not make sense. Let's see, it would not make sense connected. Okay, and I'll show you what I mean by that in a minute. Okay, so would not make sense connected together. This is going to be useful for things that are counted. So we can make graphs of all kinds of things that are things that we can count. An example of that is buying shirts. You cannot buy, as an example, 1.4 shirts, right? That's not possible. We're going to have to, we could buy, one shirt and its cost is going to be some amount. I don't, and I didn't label this over here, but if we, bought a second shirt, it might look like this, and a third shirt. So, it's going up at a steady amount. We could go ahead and give it some dollar amounts if we wanted to. Let's say it was, one shirt was $10 and the second one was 20, 30, 40, and 50. Okay. It would not make sense to connect these because it's actual numbers of shirts. Okay, so there's no meaning here, in the middle of like 1.5 shirts. Like, what would the cost be of 1.5 shirts? It doesn't exist. All right, let's compare that to continuous. This is going to be something that is graphed with a line or a smooth curve. And the data makes sense to have partial amounts. And this can be drawn, so when you are doing a continuous graph, it can be drawn without lifting your pencil. Okay, so if we did an example, we could say a road trip. You can drive, 1.7 miles. Okay, that is a possibility, right? So, as our time and our distance, like as we're driving, we might have a line that looks like this. Okay, so we can have points in between that make sense. We can drive for, 55 minutes and 34 seconds. And in that time, we might have gone, 55.21 miles. Like we can have partial amounts, and that makes sense in that sense. Okay, so we are looking at discrete is going to have like points like this. Continuous, it's going to be something like that. Alrighty, let's go and look at some examples down below. Okay, so it asks, is this discrete or continuous, and explain why. Well, when you look at this, it's a whole bunch of points, okay? So we know that this is a discrete function. If we look at the characteristics of how we know, something's a discrete function, we can come back up here and if it's continuous, we can graph it with a line or a smooth curve. There's no line here. It's just a bunch of dots. And so that's why it's going to be a discrete function. So explain why. It is, this is a collection of dots that are not connected. Okay, so that's what discrete means in that sense. There we go. It's a discrete function, and this is a collection of dots that are not connected. Alrighty, let's look at this. So again, it's asking, is this a discrete or continuous function? And it wants us to explain why. Well, let's look at this. We are purchasing games, okay? We can purchase one game and it's $15, or two games and it's $30, three games or it's $45, and four games and it's $60. It does not make sense to buy 2.5 games, right? That's not a thing, okay? So this is going to be an example. We can go ahead and highlight. This is discrete and this is discrete here. This is a discrete function. Buying games is a discrete function because you cannot buy 1.7 games. Okay, and that's just a made up amount. I just made it up right here on the fly. Okay, there's no partial amount that makes sense in that context. It's discrete because we can't buy partial games. Okay, let's look at some more examples. And if I'm going too fast, of course, just pause it. I'm recording it ahead of time, so I tend to get on a roll. You know how things are. Alrighty, let's look at example 3. Is this discrete or continuous? And we've got this. Okay, we can see that this down here with its line, with its curve, is very different than this, right? We are able to graph it with a line or a smooth curve. So that's going to make it continuous for sure. Okay, so this is continuous. Well, let's explain why. The graph is continuous because it is a smooth curve. Okay. Well, what if we were looking at something that's more like a word problem? So, this one here where we had dots, that was pretty easy. Where we had a data table, that was pretty easy. And then when we had a graph where we can see there's definitely a curve, that was pretty easy. But we can have a word problem. And so this makes it a little more complicated. We've got to read this word problem and try to decide all the things that it's telling us. So let's go in and start reading this. So you decide to launch a water balloon at a friend who is standing, so they're standing 20 feet away from you. It takes 1.5 seconds to hit your friend. Let's go ahead and draw a picture and we'll just kind of think about what's happening. Okay, so here's your friend and here's you. Okay, and there's like 20 feet between you guys. And you decide to throw this balloon. And so this is my interpretation of a balloon, and it's going to hit your friend. And it's some fun game that we are playing. Now, does it make sense? This is the question that we're asking ourselves. So the big question. Does it make sense for a balloon to travel, let's say that it travels 2.51 feet in I'm just going to make up an amount in like 0.013 seconds. Okay. And the answer is yeah. Yes. Okay. It does make sense for that. So this is a continuous function. Because, even when we drew this, even when I drew this picture, it's got this smooth arc, right? Like the balloon's going to be here and it's going to be here and it's going to be here and it's going to be here. There's like practically an infinite number of positions here and an infinite number of times that we can have along that trajectory. So this is a continuous function. Because both distance and time can be partial amounts. Okay? So they're constantly changing. It's not like buying a video game where, you have one video game and it's $15. It's not like that. You can have partial amounts as you throw that balloon. Alrighty, my friends, it's a nice short lesson today. And so until next time, bye.